Good morning, everyone. I'll be back with you in a few minutes. While you're waiting, make sure you do your attendance in the chat and then check in on the BTB.
Good morning.
Good morning. A couple more minutes to work on this BTB, and we'll let some people continue to filter into the room. Today is going to be a pretty brief session. So we're going to be out of here in about 15 or 20 minutes. We just have one new thing to cover today. So a couple more minutes on this BTB. All right, if you could go ahead and throw your hand up, raise your hand if you're finished with the BTB. All right, that's less than half of us right now. So we're going to give another minute to finish this up. All right, let's go ahead and jump in on this BTB. Does anyone recall having learned about histograms in either 6th or 7th grade math? Throw your hand up if you remember histograms. I see hands going down, so it doesn't seem like a lot of us. So this thing that you might want to call a bar graph or a bar chart is actually a histogram. So this thing right here is a histogram. And it's a little bit different than a bar graph or a bar chart. And the primary difference is that bar graphs or bar charts are generally used with categorical data, right? So if we were asking a question about like what people's favorite color was and we gave them choices of red and blue and green, and 10 people picked red and 12 people picked blue and some people picked green, a bar graph would look a lot like a histogram, but we'd have categories on the bottom like blue and green. And we'd have these bars that go up. And typically on a bar graph, there's space in between the bars. And that's because they don't actually represent something numerical. They're just a category, and it's a way of displaying how many people picked each category. In a histogram, our x-axis, that independent axis on the bottom, is numerical. And when one numerical category ends, the next one begins, and the next one begins, and the next one begins. And for that reason, there's no space between the bars. So that's something that we're going to see on all of our examples today, is there should not be any space in between our bars, because as soon as you're no longer, in this example, as soon as you're no longer 19, you are 20, which means you are either in the left bar or the right bar. There's no space in between. And then as soon as you are no longer 39, it's because you turned 40, and there's no space in between. So we are going to go ahead and see that with our histograms. Histograms should be pretty intuitive to read, I think. And when I say intuitive, I mean that we should just kind of be able to read them and understand what's going on them. Can somebody unmute really quickly and tell me how many people there are between the age of 0 and 19? How many people are there between 0 and 19?
9.
9 people, thank you. How many people between 20 and 39? Just do an unmute and answer.
6.
6. That is correct. Between 40 and 59?
11.
11.
11 people. And from 60 to 79?
3.
3 people, absolutely. So if we wanted to turn that histogram into a frequency table, which is what we see here on the right, down the age column, we would have those intervals from 0 to 19 years old, from 20 to 39 years old, from 40 to 59 years old, and from 60 to 79 years old. That would be our ages. And in our frequency, we put those numbers that we just got a minute ago. Hang on one second. Somebody's trying to come back in the room that got kicked out. From 0 to 19 is going to be a frequency of 9. From 20 to 39 is going to be a frequency of 6. From 40 to 59, a frequency of 11. And from 60 to 79, a frequency of 3. Okay, that is how we will create a frequency table from that. And then there were 2 questions for us to answer. What was the most common age of people in the library? And the answer to that one is the one that has the most frequency, which was from 40 to 59. And the second question, how many people were between the ages of 20 and 59? Anyone have any thoughts on how to answer that question from 20 to 59? Max, you want to go for it? You have to unmute, remember, Max? Or you don't want to answer? Yeah.
You add all the frequency.
Which frequencies?
I mean the first 3.
The first 3. So from 20 to 59 is going to start with which bar? Where does 20 years old start? Somebody, yep, go ahead, Max.
In the second one?
In the second bar. And where does 59 end?
In the one after.
In the one after it, right? So that's going to be the frequency of those 2 bars, 6 plus 11, and 6 plus 11 is 17 people. Okay, any questions on that BTB? Alrighty, so what we're going to do is I'm going to do 2 examples with you right now where we're going to build the histograms ourselves. So we're going to just take the data, we're going to take some raw data, and we're going to take that data and we're going to create a histogram from it. So here's our first question, and this is the first example from the PDF that was posted of today's problems. There's a list of the number of chocolate candies per bag of trail mix. So somebody sat down with a bunch of bags of trail mix and counted out how many of the little chocolate candies or the M&Ms were in each bag. And they got the following data: 50, 42, 119, 45, etc. Our job is to create a frequency table and then to create a histogram from that information. The easiest way that we can create a frequency table, our best bet here, is going to be one of 2 things really. Option 1, we can do tallies. So if we want to do tallies, then we're going to go number by number. For example, 50 is going to fit in this category and we'll put a tally. 42 fits in this category and we'll put a tally. 119 doesn't even fit in one of those categories. So we're going to have to add another category here. We're going to add the category from 101 to 120. Okay. 45, 68, 32, 67, 111, 61, 31, 75, 39, 62, 64, 49, 55, 51, 33, 117, 96, 64, that's the wrong one, 64, and 82. So we're going to create a little tally chart here, and then we'll add up our tallies in each category. So there were 4, 6, 7, 2, and 3. And once we have our frequencies, we're going to go ahead and fill in our histogram here. So from 1 to 20, there were none. So there's going to be nothing in that first bar. From 21 to 40, there were 4. So we're going to go up to 4 here. And we're going to make sure that our bar, the width of our bar, is the entire interval. We don't want any spaces as we go ahead and draw this out. From 41 to 60, we have to go up to 6. From 61 to 80, we're going up to 7. From 81 to 100, we're at 2. And then from 101 to 120, we are at 3. And a couple of things that I want us to notice about our histogram. First of all, like we said a couple times already, there's no space in between these bars. There should be no empty space between the bars. Each bar butts up against the next bar. The second thing is that every bar is the exact same width. And every interval is the same width. It wouldn't be fair for one interval to go from 1 to 5, and then the next one goes from 6 to 3 million, right? We want each size bin to be about the same size. So we're going to go ahead and make sure that each interval is the same size as well, and each bar is the same width. What questions do you have right now, if any? Or does this seem pretty easy? Can I get a hand up in the chat? Sorry, a hand up on your screen if you understand this so far. You have no questions on this so far. Oh, a lot of hands. Okay, good, good, good. I told you, today's gonna be pretty easy. We're just adding one new skill. Cool. So I'm gonna throw a blank page in here really quickly because I want to share one thing with you. Yesterday, we talked about skewed graphs. Remember, we talked about box plots that look like this. Does anyone remember what they're called when they look like this? What are these box plots called? You can just unmute and tell me if you know what the shape. This is a box and whisker plot, but what shape is this? So we talked about 3 different shapes of.
Symmetrical.
This is called symmetrical, yeah. And it's called symmetrical because the tails are approximately even on both sides, right? Versus something like this, Does anyone remember what that one's called?
Skewed right.
That one is called skewed right, and it's skewed to the right because the tail is off to the right, the longer whiskers on the right. And in the other direction, this one is called skewed left because the left tail is longer. We have the same three shapes or an equivalent three shapes in histograms. So a symmetrical histogram is going to look something like this. The most common and biggest bar is going to be in the middle of the relationship. And as you move outwards from the middle, each bar gets a little bit less common. And symmetrical graphs are pretty common in people, right? So if we were to check, let's say, on people's heights, we would find that most people are average height, right? So most people would fall in this middle bar of an average height. And some people are a little taller and a little shorter. And even fewer people are a lot taller or a lot shorter. And the further we get away from average, the further we get away from kind of the normal, I don't like that word, let's go with average. The further we get away from the average, right, the fewer people there are going to be. That's called a symmetrical shape. But we also have skewed left and skewed right shapes. So we might get a test, for example. We might have an exam that was pretty easy. On a really easy test, we might see a whole bunch of A's, and we might see some B's, and then a few C's, and a couple of D's, and maybe even a couple of F's. And this particular graph would be called skewed left, because just like that box and whisker plot that had a tail on the left, a longer whisker out to the left, this one has this tail off to the left as well. Most of the data is on the right, but there's a few little stragglers over on the left, and we call that skewed left. And the opposite might be true on a really difficult test, right? So a really difficult test, we might have a couple A's and a couple B's and a couple C's and then a bunch of D's and a whole bunch of F's, right? Something like that. A really difficult test might be skewed to the right. Those are the three different shapes that we want to be familiar with, whether we're looking at box and whisker plots or we're looking at histograms. Questions on shapes of histograms before we move to our last example together? Told you it's gonna be a quick morning. All right, so this is a little bit more practical. So when we did this example right here, I gave you a ton of information. So I gave you not only the data, but I told you how I wanted you to split the data up by using a frequency table. I gave you all the intervals, and I even created the graph for you. Everything was set up and ready to go. Realistically though, as we get to tomorrow and Friday, when you're gonna be collecting your own data again, be doing some data collection on your own and putting that into practice, you're not gonna have a setup graph for you. You're not gonna have setup intervals for you. You're just gonna get a list of numbers, something like that. Okay, so this was, I'm gonna make something up right now and pretend like it's something real. This was the total points scored by Macmillan basketball teams per game over the last 5 years, right? So we went back and found all of those. And in one game, Macmillan scored 20 points. In another game, they scored 34, 23, 34, etc. Our job is to first take this data and summarize it in a frequency table, which we're going to do right there, and then take that frequency table and turn it into a histogram right there. So the first thing that we need to do that's different than the other question is we need to decide what we want the intervals to look like. We've got to pick the intervals here. To do that, we have to understand how wide we need this graph to be. Do I need to start at 0 on this graph? Is there any numbers that are close to 0? Thoughts? What's the smallest number I need to be able to graph in this histogram? Somebody can unmute, jump in. What's the smallest number?
20.
20 is the smallest number I need to be able to graph. And that means that my first interval is probably going to start somewhere around 20. And what is the biggest number that I need to be able to graph?
55.
55 is the biggest number I need to be able to graph, okay? So we're gonna do this. We need to get from 20 to 55. And so we're gonna need to count these intervals by something that makes sense to count from 20 to 55. If we count by 1, like 20 and 21, 22 and 23, we're gonna end up with like 20 different intervals, and most of them are gonna have nothing in them. And so it doesn't make sense to count that way. we need to think about, first of all, how wide this interval is. From 20 to 55 is 35 units. And we need to be able to break that up into pieces that is going to give us like 4 or 5 bars. Even if we divide by 5, we're going to end up with 7 bars. That's not a ton, but there's not a whole lot of data here, right? So if I break this up into 7 different bars, every bar is going to be pretty small. So I'm going to recommend instead that we break this up into 5 bars. And it doesn't really matter here. This is just what I'm choosing to do because I don't want to get too many bars. We're going to break this up into 5 bars. And that means that each bar is going to be about 7 units in size. So that first bar is going to go from 20 to 27. Okay. And the next bar is going to take over at 28 and is going to run from 28 to 35. And that next bar is going to take over at 36. And it's going to be 7 units large. It's going to take us to about 43. And notice what I'm doing each time is I'm just adding 7, right? Each interval starts at the next spot and then I'm adding 7 more. This is going to go to 44 here. And this will take us up to 51. And our last interval is going to start at 52 and it's going to go to 59. And the last interval goes a little bit further than where our data needs to go, but at least it captures all of our data. Okay? So that's how we're going to run our intervals. And now we're going to start our tallies. So I'm going to pause right here and I'm going to ask you in your notebook to take 2 minutes to sort this data out and see what you come up with for your frequencies. Alrighty, so I have my tallies up on the screen there for you to be able to look at your work and make sure that you are agreeing with my frequencies. And I think the last thing that's kind of helpful for us to check to make sure we did it right is if we add up all of those numbers of 5 plus 5 is 10, and 6, 16, 17, 18, 19, 20. There's 20 numbers in my chart, and there were 4 by 5, 20 numbers in the original data, just to make sure we didn't miss something along the way. We want to make sure that those numbers total up. And we are now going to set up our histogram. In our histogram, on the y-axis, we're going to write frequency, right? How often did something happen? Frequency. And on our x-axis, we're going to put our intervals. And I think I have room to do this. Let's see this. Yeah, I do. Okay. I have room to make each bar be 3 units wide. And we're going to go from 20 to 27, 28 to 35, 36 to 43, 44 to 51, and 52 to 59. Our first bar is going to be 6 units tall. 3, 4, 5, 6. Our next bar will be 5 units tall. 5 units tall. 2 units tall. And 2 units tall. And so that is more or less what my resulting histogram. That's so neat and organized. I'm really good at drawing straight lines. That's more or less what my resulting histogram should look like for this data. What shape do you think that is, and what does it tell you about the basketball team? Anyone want to tell me what shape that is? Just unmute if you want to tell me what shape that is.
It's skewed to the right.
It's skewed to the right. Does anyone know what that means about my basketball team?
Less of them, Mr. Can I answer?
Yeah, go ahead.
Okay. Less of them got like an overwhelming victory.
Yeah.
More of them,
Yeah. Most of the time we weren't very good, right? It means most of the time we didn't score a lot of points. On occasion, every once in a while, we had a game where we scored a lot of points, right? This was skewed to the right. All right, so what questions do you have for me before I let you ride? Any questions this morning about histograms? Alrighty, then we have a pretty quick morning this morning, I think. About 20 minutes of me talking, and you guys can jump in and do the extra practice. There were 3 questions posted today. One of them we did already. It was the first example we did about chocolate, the M&Ms in the trail mix. It was this one. And you just need to do the other 2 in your notebook this morning and make sure you're clear on how to create histograms. Alrighty, if there are no questions, you can have a great day.
I have a
Bye, adios, have a good one.